Bismillahirrahmanirrahim. So today our topic is anionic polymerization. So as we could see here that this is anionic polymerization, there is something, anion has some role to play. Now as we have seen the cationic polymerization, that cations, they actually act as the in the chain initiation step, we have generation of cation from the monomer. In case of anionic polymerization, we have an anion is getting generated. Anion is generated in this anion is generated in the initiation step. That anion is generated from the monomer. And now this can be generated by uricarian initiators. Very important thing is uricarian initiator. Just like in the cationic polymerization, we have the initiator like those, the initiators which can actually like acids in that case, whether it is Lewis acid or whether it was their protic acid. So in this case, we require initiator. Those initiators they are usually alkali metal suspensions. Alkali metal suspensions. So, and that usually we have sodium in liquid ammonia. Usually you have sodium in liquid ammonia. And you may have Grignard's reagent also. You may have RMGX, halide magnesium, and this is alkyl, the Grignard's reagents. So, and you may have alkyl lithium, aryl lithium type of agents also. So we require an initiator in the anionic polymerization that can actually initiate a process that will generate the anion, and that anion which is generated in the initiation step, and that will attack the monomer in the propagation step, and in this way the chain will propagate. For example, so now there's another question. Before we proceed to the process, the mechanism of initiation, propagation and termination, important thing is that this type of process occurs in the monomers which have electron withdrawing groups. So those monomers which have electron withdrawing groups, this is very important, electron withdrawing groups, monomers with electron withdrawing groups. And usually you will see the groups like cyanide, for example, in styrene. Cyanide, that is styrene, or it can be acronitrile. So styrene, this is, then you have CH. This is styrene. Now this is a benzene, fine. So the monomers, they must have electron withdrawing groups, so they can actually stabilize the cation, fine. So acronitrile, or I can write here styrene. For example, styrene, there has presence of electron withdrawing group, and then you can have acronitrile. Acronitrile is vinyl derivative, CH2, CH and Cn. So it has this electron withdrawing group. So those monomers, they are usually utilized during this anionic polymerization, or when we form the polymer of polyacronitrile, or when we form polymer of polystyrene. So overall we have 3 steps. As in the cationic polymerization we have 3 steps. Okay, step number 1. So the step number 1 we have, So the reaction takes place in this takes place in 3 steps. Step 1. Step 1. Initiation step. Initiation step. Initiation step. इस स्टेप में क्या होता है कि इंसेशन प्रोसेस स्टार्ट हो जाता है एंड इन दिस केस हम लोग क्या यूज करते हैं वी यूज द इनिशिएटर हम उसको ऐड करते हैं मोनोमर में तो मोनोमर में द इनिशिएशन स्टार्ट्स कैसे स्टार्ट होता है सिंस हमारा जो ये जो इफ यू सी इन दिस केस तो यहाँ पर हमारे इनिशिएटर्स रहते हैं देयर आर एनाइंस सो सिंस इनिशिएटर्स जो है देयर आर एनाइंस ठीक यहाँ से एनाइंस आर नेगेटिव ठीक यहाँ से NH2 नेगेटिव तो इसी तरह से यू है anion initiator so we'll write that initiator as Nu so it's a nucleophile so that attacks our monomer so if you take a general monomer for example CH2 and this is X electron withdrawing group so it attacks here which is away from this electron withdrawing group so that the anion generated here that will be stabilized by this electron withdrawing group. So the monomer attacks here. So you have nucleophile here, and then you have CH2. That's it. Now this is formed, or this species is formed in the initiation step. And now this anion which is generated, that's what's called an anionic polymerase. You have anion formed in the initiation step. Now this anion then attacks the monomers and then it propagates the chain. Fine. So then we have step number 2. Step number 2. That is propagation step. Propagation step. So in the propagation step, it's very easy now. The anion which we have here. So we have a nucleophile here. Then we have CH, CHX. Now that attacks the fresh monomer. So that attacks the fresh again at the end, which is away from this electron withdrawing site. So in this case, then the process continues. So you actually have. Now I will show it in the nutshell here. The space availability. So you have nucleophile at this end, and then CH. And you have anion here. So this species continues because of the space. Here I'm not showing it both, otherwise they are both. So this way the chain propagates. It goes on adding monomers each and every time. At the end it has a negative charge, it has an anion. That's what it's called anionic polymerization. So this is the chain propagation step. Now we have the last step, that the chain termination. So the step number 3 we have chain termination. Chain termination. तो चेन टर्मिनेशन में क्या होता है कि वो चेन जो यहाँ ग्रोइंग चेन है दैट हैज टू बी टर्मिनेटेड, दैट शुड बी स्टॉप्ड. ठीक, अब स्टॉप के लिए यहाँ पे बहुत सारे ऑप्शंस है. या तो आपका मोनोमर दे विल गेट कंज्यूम्ड. ठीक, if the monomer gets consumed, when the monomer whole gets consumed, it will get automatically stopped. Otherwise we can do is that we can add the impurities. जो usually होता है कि add impurities, foreign impurities. That can be carbon dioxide, that can be water, and so on. So these are the impurities we add usually in the chain termination step of anionic polymerization. And there is one more option that we can use. The chain transfer mechanism can also happen. Chain transfer. So the termination may occur through chain transfer mechanism. ये हमने last में discuss किया था. ठीक. So that can happen through the chain transfer mechanism. अब in case of अब यहाँ कार्बन डाइऑक्साइड के केस में क्या होता है? For example, we'll take this monomer site here. Overall, we have here X negative. ठीक. So this is our species which is generated in the propagation step. So if it reacts with carbon dioxide, it forms. Since water is there, so it will form. So it will get blocked. That gets terminated. You got a carboxylic acid from. So if you add a water, that water will give the proton directly. So next step is if you are adding water, you can show it like this shortcut. You know, in presence of water, that will take the proton. So in presence of water, that will take the proton, and then you have the chain blocked, terminated. So you have terminated chain here. Fine. And chain transfer mechanism ने पहले ही कहा कि chain transfer में that one of the species that gives us the proton and that forms a double bond. ठीक. जैसे मिसाल के तौर पर let us go to this point here, that chain transfer. I don't want to rub this board so that I can show it again. The chain transfer में, for example, one more option is you have NuCH, your X here, then negative. Now we have a monomer, for example. Monomer is that हमारा जो monomer है, it's like this. X. पर इससे क्या होता है in this case कि यहाँ से some H will come out. ठीक. या इसमें ये भी हो सकता है, for example, make it like this. For example, हमारा जो propagation step में निकलता है nucleophile. This was our species formed in the step number 1. So यहाँ पे देख सकते हो in this step. So these are the two species. Now next species में क्या होगा? So in one of the species, for example, this will get this proton will get removed somehow. This one, this H positive will get removed. This will get removed. This one, this will go removed from here. Then you have double bond here formed. ठीक? Now ये proton, this H negative, it will go to somewhere else. ठीक? See, it can form a double bond here. So once it is formed a double bond here, it leaves this H hydride, forms a double bond here, so that gets terminated. ठीक है ना? तो ये दो different chains के दरमियान भी हो सकता है, या it can occur between this and the monomer. So this way the chain transfer occurs. So but usually we have the impurities like carbon dioxide and OH. We add like CO2. We actually purge this carbon dioxide into it. Then it gets terminated. These are most common termination mechanisms. So this is all about the anionic polymerization. Again, you can see here. So you have basically the anion generated in the initiation step. That's what's called anionic polymerization. It's being initiated by the initiator. It can be alkali metal suspensions like liquid ammonia. It can be a Grignard's reagent. And then it usually occurs with the monomers, which those polymers which monomers possess the electron withdrawing groups. So, and then the process starts initiation, termination, propagation and termination steps. So I hope you enjoyed this presentation.